Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 11 Maths Trigonometry, Trigonometric Identities and the reduction formula. The question paper that we're going to be looking at is the November 2019 paper 2, and this is part 1 of the series of videos. So let's get straight into it. In question 5, it says, in the diagram below, P, K and 24 is a point in the second quadrant such that OP is 25 units. N is a point on the positive x-axis and PON is equal to theta. The first thing that we need to do is we need to understand our cast diagram. For example, in our cast diagram, we should know the following. So there you go, there's your Cartesian plane, there's your origin. That's your x-axis, that's your y-axis. It's important for us to remember that our Cartesian plane starts from the positive x-axis and it moves in the anti-clockwise direction, 0 degrees, 90 degrees, and then we'll get 180 degrees, 270, and then we come all the way back here 360 degrees, completing our revolution. Remember, all angles are measured in an anti-clockwise direction starting from the positive x-axis. Thereby, this will be the first quadrant, will be the second quadrant, that's the third quadrant, that's the fourth quadrant. Now remember that because x is positive in the first quadrant and y is positive in the first quadrant and r is always positive, that means that all trig ratios are positive in the first quadrant. It's important for us to remember our formula for sine, cos and tan. Remember that sine of theta is equal to y over r, cos of theta is x over r, and tan of theta, theta being our reference angle, tan of theta is y over x. This is the same as saying opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Remember, y is your opposite side and r is your hypotenuse, x is your adjacent side. Now you can actually work out where all of your ratios will be positive or negative by substitution. See, in the second quadrant, x is negative and y is positive. So therefore, if you look at that, see y, and remember r is always positive. Thereby, we say sine, the only ratio that's going to be positive in the second quadrant. Similarly, in the third quadrant, remember x is negative and y is negative. Therefore, a negative over a negative is positive. Thereby, only tan will be positive in the third quadrant. In the fourth quadrant, remember, now that x is positive and r is always positive, therefore cos of theta x over r now, so that will be positive over positive, which is positive. So therefore all sine, tan, cos, and there are so many acronyms that you can remember this by. So that's the basics of what we ought to know, and I'll come and add to this in a while. So let's have a look at, firstly, let's complete our diagram by dropping down this perpendicular. Remember that they tell us that P, K and 24 is a point in the second quadrant. Second quadrant, remember, second quadrant, x is negative and r is positive, y is also positive, right? So that's your x value, that's your y value, such that OP is 25 units. And you can clearly see OP is going to be my radius or my hypotenuse, okay? Remember, I'll get a radius if I have to complete a circle around all of these points. This will be r. My radius is 25. X, so that's going to be K, and Y is 24. Now, learners, let us complete and find the value of K, which is most likely going to be the first question. Calculate the size of, or calculate, or without calculating the size of theta. Theta is our reference angle. Determine the following. So the first thing that they want us to find is K. We can find K using the theorem of Pythagoras. Remember now that this is my x value, so it will be, and I got r and y, so it will be k squared is 25 squared minus 24 squared, using the theorem of Pythagoras, which states in a right angle triangle the square on the hypotenuse is equal to the sum of the squares of the other two sides. So let's go work that out. 5.1.1 5.1.1, we'll say k squared is equal to 25 squared minus 24 squared. 25 squared minus 24 squared, and we are using the theorem of Pythagoras. That's now equal to, let's use our calculator, 25 squared minus 24 squared equals to 49. So k squared equals to 49. Therefore, we can say k is equal to plus minus the square root of 49. And then we can conclude that k will equals to, let's see, square root of my answer equals to 7. But remember that k is in the second quadrant and x is negative, therefore x is a negative value. So k is going to be minus 7. Therefore, we can now say that k is going to be negative 7, second quadrant. So let's go fill that on our diagram, right? K is equal to minus 7. The next thing that they want me to find here is tan of theta. Tan of theta, let's go look at that. Tan of theta is y over x. So therefore, my y value is 24 and x value now is minus 7. So that will be my answer. 24 over minus 7. Let's see, 5.1.2. 5.12 tan of theta equals to y over x. So that will be 24 over negative 7. 24 over negative 7. 24 over minus 7. 5.1.3. We want me to find sine of alpha if theta plus alpha is equal to 360. Remember now that our angle is given in terms of theta, so our reference angle is theta. So what we got to do here now is we got to now firstly say that alpha is going to equal to 360 minus theta. So 360 minus theta. Now this is going to introduce us to the reduction formula. So 5.1.3, let's write that down. 5.1.3. we can just say that sine of alpha is equal to sine of 360 minus theta. Let's write that down. Sine of alpha is equal to sine of 360 degrees minus theta. Let me just do a brief introduction to the reduction formula. Now let's go back here. First, second, third, fourth quadrants, which I've already explained. The first quadrant is theta, second quadrant is 180 minus theta. The third quadrant is 180 plus theta. Bit of a tight squeeze here, and here will be 360 minus theta. So those are my formulas for each one of my quadrants. But remember that if you come back now into the first quadrant, any angle which is greater than 360 degrees can be reduced by using the 360 plus theta, and that will always reduce to a positive value. I'll explain that a little bit later as well. But now, let's look at this. 360 minus theta is in the fourth quadrant, and this one here pertains to the question that we are answering. 360 minus theta, so it means that only cos is positive in fourth quadrant, right? So what does this mean? It means that this is going to reduce to a negative, so it's going to be minus sine of theta. There you go, because only cos is positive in the fourth quadrant. So we need to remember our formulas for each one of the quadrants. Okay, so for the fourth quadrant, every time you see 360 minus theta, you think of the fourth quadrant. Now, let's go look at sine. Well, there's just sine is y over r, and my y value is 24 and r is equal to 25. So the answer will be 24 over 25. Substituting there, so therefore I'm going to get minus 24 over 25. There you go, that's the solution. The next question is 5.1.4 cos squared theta minus sine squared of alpha. So once again, they're giving us alpha here, and we know now alpha is 360 minus theta. So let's write that down. Cos squared theta, 5.1.4, 5.1.4, let's say cos squared theta minus sine squared of 360 minus theta, because alpha is 360 minus theta. So we'll say minus sine squared minus sine squared of 360 minus theta Now we can reduce that sine squared of 360 minus theta to, I want you to pay careful attention to this, whenever a function is squared, it's going to reduce to a positive. Why? Let me explain quickly. You see, we got minus sine of, or rather minus sine squared of 360 minus theta. You're going to end up with sine of 360 minus theta times sine of 360 minus theta, which is actually going to give you minus sine theta times minus sine theta. And we know a negative times a negative is a positive. Alright, so just remember that when a function is squared and you want to reduce it, it will always reduce to a positive value, because that just comes from the multiplication of signs. If you multiply negative times a negative, you get positive. Positive times positive is positive. Okay, so therefore cos squared theta minus sine squared theta. So that just now leaves me with substitution here. Cos squared of theta. Now what's cos? Cos is x over r, and we've already discussed that one. X over r. So it'll be minus 7 over 25 all squared. So let's write that down. Minus 7 minus 7 over 25 all squared minus sine squared theta is y over r. My y value is 24 over 25 all squared. Let's write that down. 24 over 25 all squared equals 2. And let's go put that in our calculator. So here we got minus 7 over 25 squared minus 24 over 25 all squared equals to minus 527 over 625. Let's write that down. Minus 527 all over 625. 625. Now let's go look at our next question. Now in the next question here, still dealing with the reduction formulas here. Simplify without using a calculator. Cos of 210 degrees times tan of 135 all over sine of minus 60 times cos of 420. Now let's look at each one of these separately. Cos of 210. Now for cos of 210 degrees, what is that going to equal to? Now we need to use our reduction formulas here, right? 210 degrees lies in the third quadrant, as you can see, right? It's between 180 and 270. So therefore, we want to use our special angles. What is a special angle? Special angle is any angle between 0 and 90 degrees, which is now going to be 0, 30. When I say any angle, I mean 0, 30, 45 degrees, 60 degrees, and 90 degrees. Right? So remember, from 0 to 90 degrees, right? But we normally will get between 0 and 90 degrees, which is 30, 45, and 60 degrees. It's important for us to know our special angles. So we need to know sine, cos, and tan of 0, 30, 45, 60 degrees, and 90, all the way up to 90 degrees. Okay, and these are referred to as special angles. So what we want to do is that every time you get a question like here, 210, you're going to write it in terms, well, in most cases, right? If you do get the odd case where it's not going to reduce to a special angle, then you're probably going to be tested on what we call complementary angles. And I'll talk about that when we get an example that deals with complementary angles. But for now, see 210 lies in the third quadrant. So what is 210? Using this formula here, 4 is going to be cos of 180 degrees plus 30 degrees. Now what is that going to reduce to? Now remember that in the third quadrant, let's go back to the third quadrant. In the third quadrant, remember only tan is positive. So therefore your other functions are negative. Therefore it's going to be minus cos of 30 degrees. Now cos of 30 degrees. Now we normally will teach you that you need to learn your triangles for your special angles, okay? But I'm going to tell you which ones you need to learn in terms of special angles. Now for this one, you can use your calculator. Cos of 30. Cos of 30 should give you an answer of the square root of 3 over 2, root 3 over 2, alright? But you can double check using your calculator. Cos of 30 degrees equals to root 3 over 2. So therefore that's going to be minus the square root of 3 over 2. Now, when you are writing your solution down, the first thing that you must do now is when you see this cos of 210, you don't have to write this first step here, which is cos of 180 plus 30. You can just write minus cos 30. Alright, so let's just go and do that. So that now will be 5.2, 2. So I'm just going to write down minus cos 30. So cos 210 is going to be minus cos of 30 degrees times. Now let's follow the same process, right? So tan of 135 degrees. Now 135 lies in the second quadrant, right? Because you can see it's between 90 and 180. So 135 lies there. So you have to use this formula. 180 minus what angle will give you 135? Well, there's it right over here, 45 degrees. 180 minus 45 will give you 135. Right? If you're not sure, just go double check using your calculator. 180 minus 45 equals to 135. Right? So you're going to get tan of, so let's go write that down. So basically it will be tan of 180 minus 45 degrees, which is equal to, remember now in the second quadrant tan is negative, so it will be minus tan of 45 degrees. Now tan of 45 degrees, if you have to use your calculator, right? Tan of 45 degrees is 1. That's the easiest one to remember. But if you are still learning your special angles, tan of 45 equals to 1. You can just double check using your calculator. So therefore that's going to be negative 1. Right? So now we've done the second one. So what you're going to do now is you're going to write down, minus tan of 45 degrees, right? Because you can use brackets. Use brackets, it's important, especially when you got negative values, right? Now, the next one will be sine of minus 60. Sine of minus 60. Right? So sine of minus 60 is going to be as follows. Now, you need to know your negative angles. Like for example, sine of minus, let's use theta, is equal to minus sine of theta. Cos of minus theta equals to cos of theta. Tan of minus theta equals to minus tan of theta. So you take away from the special angles is that only cos of a negative angle is positive. The other ones remain negative. So what are we being tested on here? We're being tested on the following. It says here that sine of minus 60 is going to be, sine of minus 60 will be what? Minus sine of 60 degrees. And 60 degrees is a special angle, right? There you go. See again, special angle. So therefore, you can now go and put that in the calculator. Sine of 60 degrees. Sine of 60 degrees. See, and then here you should get root 3 over 2 again, right? So root 3 over 2. So therefore, what is that going to become? So minus sine 60 will be minus square root of 3 over 2. So first thing that we're going to go right down there now is following. So let's firstly go down. So that line will be minus sine of 60 degrees. And what are we left with there? Last one now to do. Times cos of 420. As discussed now, I said that if any angle is greater than 360, it's going to reduce to the first quadrant. It's going to go back to the first quadrant. So 360 plus 1, I will give you 420. Right? So there you go. 360. Let's have a look at that. Plus 60. 360 plus 60, and there's another special angle. 360 plus 60. You can double check here. 360 plus 60 equals to 420. So there you've got your next special angle. Let's write it. Cos of 360 plus 60, because remember we were given cos of 420. There's cos of 420 there, which reduces to cos of 360 plus 60. So remember, any angle now which is greater than 360 can be reduced like this here. Or you can just subtract multiples of 360 from it, right? That's another way that you can do it. But I'm just illustrating here the formulas in this particular video, right? One way you can do it is just keep on subtracting multiples of 360, right, until you get to a special angle or an angle between 0 and 90 degrees. So now this will always reduce to a positive. Okay, so this is going to be now cos of 60 degrees. Cos of 60 degrees should give me half. You can use our calculator for that one as well. Cos of 60 degrees is equal to half. So what you're going to write? You're going to write cos of 60 degrees there. So here for your solution you'll say cos of 60 degrees, and now we'll just write what? Minus root 3 over 2 times there minus 1. Okay, now I showed you how we get all of that already. I used the calculator. Minus sign of 60, that will be minus root 3 over 2. Okay, 1 over half, which is going to give us minus 2. Once again, if you wanted to, you could use a calculator here. Minus 1 divided by half, and that should give you minus 2. Now let's quickly look at the work schedule. You can see that we've covered quite a bit of trigonometric identities and the reduction formula in this series of videos. If you haven't subscribed already, subscribe to JR Maths. You can also like my Facebook page, which is Justin Lazarus Mathematics. And you can watch all videos in order of the work schedule on jrmaths.com. And I'll catch you in the next video.